Hello, my name is Morgan James, and this is my tutorial on how to use Unity shaders leading up to a shader that when you hover over a shape, it will outline it with a blurred and distorted border. Great, so let's get right into it with a new Unity project. Now that we're in our new Unity project, I'm going to show you how to create a simple shader that puts on a material to an object. So the first thing you want to do is go over to the project and create a shader, and you could just do an unlit shader, and then we're going to name it Apply Texture. Then you can go ahead and open that up in Visual Studio by double clicking it. Okay, now that we're in our shader, we can go ahead and delete everything because we're going to remake it ourselves. So you can keep this because that's saying that the shader is a shader and it's going to be saved in unlit apply texture. But we can actually change unlit to custom. Oh, custom apply texture. Oh, custom. Okay. So now if we save that and go back into our Unity project, if we make a new shape, so we create 3D object cube, and we can go to the cube, the default material will be that. So if we create a new material, create material, and we'll call it texture. And then we can change the shader to our custom, which is the folder we made, and then apply texture. But right now it's not going to do anything. So you just put that on there. It's just going to put pink because that's like the default color. Alright, so let's go back in and set some stuff up. The second thing a shader needs is properties. So if we go ahead and define the properties, like this. And now properties are basically variables that we can change inside of the editor. So we can define a texture to put on it, so main text, and then we can go, this will be the name of the thing, main texture, and we can say that it uses RPG. And then we can go ahead and say that it is a 2D texture, like that. And then you can default it to white. So if there's no texture, it'll be white. And then what this does is that it allows for a texture property. And so now if we go back into Unity, we can see that you can now add a texture to it. But if we add a texture like this, it just won't do anything because we're not using the texture for anything. We're just saying that it uses one. Alright, so let's go back into the code. We can define a couple more things. We can define color. So it's going to be it's going to call it color in our code. And it's going to be a color. And then we can set the default to 111. So it's going to be white as default. So this allows for a color property. And then we can go ahead and inline because there's no IntelliSense on this. Alright, so now if we go back into Unity, we can see that there's also a color. But again, changing the color won't affect the texture as we're not using the color or the texture on the actual shape. We're not telling it what to do with it. So let's go back into the code, and we're actually going to do something with it. So let's go down here, make a sub shader, like that. Go ahead and get rid of that. And then inside of the sub shader, we want a pass, like that. A pass is when something is shaded once. So inside of this sub shader, we can have multiple passes and so it'll be rendered multiple times, like that. But right now we're just going to stick with one. Next thing in our pass we need is a CG program statement. and then also an end CG program statement. And so what this is going to do is going to allow for two different languages to talk to each other. The first is the shader lab, which is Unity's version of shaders, and then the CG program, which is NVIDIA C for graphics. So we just type that out. Thing we're going to have to define is the function definitions for the program, and every shader contains a vertex function and a fragment function. So if you go ahead and define the vertex function, like that, and then what this does is it is a define for the building function. So a vertex basically gets all the information about the shape and tells the program how to build it. And then the other thing we're going to need is a fragment shader. Oh, pragma. And then you can just call that frag. And then what this does, it is how it colors it in basically. So define for coloring function. So this one tells it how to build it, the shape, like what shape to build it in, and then this one tells it what it's going to look like. So what color, how the alpha, everything like that. Oh, function. Yeah. Cool. The next thing that this shader needs are includes. And so we're going to include, so hashtag include, and then unity cg.cginc. Now what this does, it is a library of built-in functions for shader writing. Built-in shader functions. And so this just includes a bunch of different functions that we can use to make our different shaders. Cool. Great. Now that we have our includes, we can start to define some structures on how things get data. So the first structure we're going to define is the app data. App data basically says how the vertex function is going to get its information. So if we go ahead and define that, app data, like that, and then float for the vertex, and that's going to be its position, and this is a semantic position, and then we have a float to UV, and that's going to be a text chord 0. So it's going to be the coordinates of it. You can go ahead and inline that. There we go. And then the second thing we're going to need is a structure for how the fragment gets its data, the fragment function. So we're going to need a v2f for vertex to fragment, like that. And then we're going to need, again, a float for position. We can just call it pos. And then we're going to need that as position. But if you just have position like that, it won't work on certain platforms like PS3 and some other platforms. So you're going to have to include SV_position. And then that will just allow it to work on the other platforms as well. And then you can have float to UV text chord 0 again. Great. So this is how the vertex gets this information, and then this is how the fragment gets its information. Nice. Next thing we have to do is get the imports. So what this is basically is we're getting the properties again, so the main text and the color, and since this is in the shader lab language, we're going to have to put it back into the CG program language, and we're going to have to re-import it in. So this is how you do that. You just define what it is, so float for, and then you can have color, just like that, and then you're going to get a sampler, 2D, and we'll call that main text because that's what we're re-importing. So they have to have the same name as above here, and so that will re-import it so we can use it in our vertex and fragment functions. Great. On to the vertex function, which builds the object. So the first thing we're going to say we want to return is what goes into the fragment shader, or the fragment function, which is going to be v2f, so vertex to fragment. And then we're going to say the name of the vertex function, which we put up here, which is vert. So we're going to call it vert. And then we're going to say what it goes in, so the app data. And then we can just call this in, so the information that's going in. Then we're going to need to define a new v2f structure, and we'll call it v2f out, so we're just going to output. And then we're going to say out dot pos is going to equal to unity object to clip pos, and then we're going to get the in dot vertex. And what this is going to do is going to take the object from the object space and put it into the camera clip space. So it's going to allow it to appear on the screen. And then we can go ahead and set the out.uv equal to the in.uv. So just swapping the in's UVs to the out's UVs. And then we can go ahead and return out. So we put in the app data into here, into in, and then we've converted it into a vertex to fragment, and so it returns that. Awesome. To the final part of the shader, the fragment function, which calls it in. And so we have to say what it outputs, and it's going to be a fixed 4. And then we're going to name it the same thing, frag, as up here. And so now we're going to say what goes into it, so a vertex to fragment, and we're going to call this in. And then we got to say that it outputs as an SV target like this. So that's basically saying the color of the final thing. You can also have like SV target 1 and 2 and 3 and 4 and so on, and this just says the different like output colors. And then we're going to need a float for the text color. Text color equals text 2D, and then we can get the main texture. So, oh, this has to be capital. Main text, and we can say it's in.uv. So what this basically does is it gets the texture and wraps it around the UVs of the object. So it gets the texture and it just wraps it around the object. And then we can return the text color times by the color we put in at the top and that we imported. So this color, which we can change in the editor. So it will get the texture, wrap it around the thing, wrap it around the object, and then you can return the color times by the color, so you can like tint it different colors. So this should work now. If we save that, go into our Unity project, and then we can select the color. Oh, it says main text is not done. Because I forgot to capitalize the T here. Oh, I pressed Control T. Oops. Control Shift T. There we go. And then save that. Go into the Unity project. There we go. It's working. So if you see, you can go into the shader and you can select the texture. Select anything and you can change the color to whatever you want. And that's basically what the unlit shader is, but not including the lighting and stuff like that, and the surface shader. So that's the basic shader done. The next thing we're going to go through is how to create an outline around the shape. And so we're going to make a new shader. So create, or you could just duplicate this one. So Control D, and we're going to call this outline. And then we can go ahead and open that. And we can change it from, not from custom, but from apply texture. We can call it outline. Cool. We're then going to need to add some more variables for the outline. So if we go ahead and make an outline material, so outline text for outline texture. And we can just call that outline texture. And then we can make it 2D. And then we could just equal it to white again. Like that. And then we're also going to need an outline color. And just do 1, 1, 1, 1. And then the last thing we're going to need is an outline width, so how big the outline's going to be. We can just call that outline width. Oh. And then this is going to be a float, so we can have a range, and we're going to have a range of 1 to, let's say, 10. And then we can set the default value of this to be, let's say, 1.1. I gotta close that off so that it starts a bit bigger than the actual shape. Okay, cool. Now that we have our variables, we're gonna need to set up another pass for the outline. So this normal pass will set up the shape, just the normal shape, and then we're gonna need another pass to render the outline by itself. So you're gonna have to render it twice, once for the full shape and once just for the outline. So if we go ahead and copy and paste this pass, and then I'm gonna reformat it because it has moved all the tabs around. So one sec. Now that we've reformatted the new pass, we can go ahead and give it a name. So just call it name, and then we're going to call this outline. You can give it full caps, outline. And then that is going to name the pass if we ever want to use it in a different function. And then we can also name this pass, and we'll just call it object, because it just renders the object by itself. Nice. And then we can go ahead and change the imports for the outline. So instead of using color and main text, we're going to want to use outline text. So if we go here, outline text, outline color, just copy these over the top. And then we're also going to want a normal float for the outline width. Oh, it's up here. With our new imports, we can now actually set up the outline vertex function. So the only thing different in this is that you're going to put in dot vertex and then dot xyz and then times the outline width. Sorry, it's times equals the outline width. And what this is going to do is going to get all the vertexes of the shape and it's going to times it by the outline width. And so it's going to make it either the same size if it's 1 or bigger if it's more than 1. So it's going to make the shape, it's going to get the shape and then it's going to increase it a bit bigger than the actual shape size. And then the actual object will also render, but this will just be the same size. And then one more thing we got to do in the fragment shader is change the main text to outline text. So replace the main texture with the outline texture, and then the outline color replaces the normal color. So now this should work apart from one thing, which I'll show you in a sec. So if we go ahead and run the game, now you can see inside of Unity we have the apply texture on. So if we go to custom and then go to the outline, now you can see that there's a box, and then inside of this box is actually the original box, but you cannot see it because Z writing is still on. So if we go back into the shader, underneath the name you can go ahead and turn Z right, and then you can just write off, and you don't need a semicolon. And then we're also going to add tags like this. And what this is going to do is going to be some predefined things. So we can say Q and then equals transparent. And I'll show you what that does inside of Unity. So if we save that out, go into Unity. Now, if we click on our object, we can see at the bottom it says render Q from shader. And if we click on transparent, it equals 3000, and from our shader it equals 3000. So this is just what basically what when it renders. So if we go ahead and duplicate the cube and move it behind, we can see that since this is transparent, it will render above the other anything behind it. So it will render like closest to the screen, so that we have a nice border effect now. Cool. So now that we've made the border, we're going to go ahead and make a blur shader to add to this border shader later on. So if we go ahead and we can actually duplicate the outline. So Control D again, and we'll just call this blur. And we're going to be using a Gaussian Blur. Now that we're inside of our blur shader, we can rename it to blur, and we can get rid of these variables and replace them with a intensity. So we can call this blur intensity, and a range from 0 to 1, and we could set the default to 0.1, and then we also need blur radius, so you can call this blur radius. And that's also going to be a range, but from 0 to 20, and we could set the default of this to 1, and then let's actually change this one to 0.1. Cool. We can go ahead and change the name of this first pass, and we call it horizontal blur, because we're going to do 2 passes on this blur. We're going to do a horizontal blur, so going across, and then we're going to have a vertical blur going up and down. Okay, so we could take the Z writing off. I need to add a grab pass here, just above the actual pass. And what this is going to do, it is going to get the object, everything behind the object is going to render it and send it through down to this pass, the horizontal blur. To start off, we're going to need to change the imports. So we can get rid of these and replace them with blur radius. We can copy that one, put it here, and get the intensity. And then instead of sampler 2D outline text, we're actually going to get a grab texture. And this is going to be the texture that comes from the grab pass, so everything that is behind the object. And then we're also going to need a float for, and this is going to be grab texture underscore texel size. And we'll get to what this means in a minute. The S actually has to be capitalized like that. And so this imports the stuff we actually need into this. And then we can actually get rid of app data, because basically what this contains can also be inputted into the vertex by going app data underscore base, because this is included in the built-in shader functions. So we don't actually need app data. But with the v2f struct, we want to change this to vertex, so position to vertex, and then UV to UV grab, and also change it to a float for. Down to our vertex function, we can get rid of the amplification of the shape, because this is just going to go on the actual shape itself. So get rid of that. We can change the out vertex to be equal to the camera's clip. So like it gets the object and puts it into the camera's perspective, and so that's right. And then we can go ahead and, so that's almost right, but there's one thing wrong with it. When we go like this, it's gonna change the whole camera. It's gonna put the whole camera's perspective onto each face of the shape, and so we need to add this. So out dot uv grab dot xy equals float to out dot vertex dot x, and then out dot vertex dot y times scale, which we'll define in a second, and then plus out dot vertex dot w, and we'll times all that by 0.5. And that will make it so that it only gets what's behind the actual object, instead of the whole screen projected onto each face of the object. And then we can get out dot uv grab dot zw and we can get rid of this, and then we're going to define the scale. And we define the scale because on certain processes, like if someone's using DirectX or some other platforms, the UVs on materials and textures read upside down, just because of the differences in the hardware and the software. And so you need to put this statement: Unity UV starts at top, and then float scale equals -1. And then if it isn't using it, then we could just use the default way it reads scale. I could just replace this one sec. Scale equals 1, and then we can end it, end if, and then tabify it in. And then this should be good for the vertex function. And we're just gonna remake this, so we can change it to half 4, and then the name of the fragment function, frag v2f, and then what's going into it, and then this is gonna output the color, so the color of the actual shape and object, and then we can make a half 4, and this is going to be text call, so the texture's color in the end, and this is equal to a text 2D, and then grab texture, and then unity proj underscore chord, and then in dot uv grab, and that should be good. Apart from text 2D should be with a proj at the end of it. So that will get the everything that is behind the everything that the grab pass got us. So everything behind the shape, it will put into this a material and put it into here. Okay, and then right at the end we can say return text color. So it returns the texture's color, but we want it blurred. So this is it not blurred, and it returns it not blurred. So if we go ahead and add a new version of it, so half for text sum, and we're just going to equal it to nothing right now. So half for 0, so initialize it to just that color. And then at the bottom, so when we change text sum in a second, we can say text call equals lit, and then text call text sum, and we can loop it by the intensity, so underscore. So what this is going to do is going to loop between the no color, so no blur, and once we set this to be a blurred version of this, it's going to loop between no blur and blur by the intensity. So for the intensity is 1, it's going to be all the way to text sum, so all the way blurred, and if the intensity is 0, it's just going to be a default of text call. Alright, now we can go ahead and start to add the half of the Gaussian blur, which is the horizontal pass of the Gaussian blur. There's an algorithm for Gaussian blur I'm going to put in the notes, and so you can look at that of how it works, but right now I'm just going to define like a small function, define grab pixel, because how Gaussian blur kind of works is you have multiple pixels. So say if there's like you have the one pixel in the middle, and to blur it you want to get the color of all the pixels around it and take different values of that color and combine it and average it out and make the pixel that we're talking about that color. So it's basically an average of all the different pixels colors around it, and this pass only does the horizontal, so only pixels that are to the left or to the right. And so to start, we're going to say grab pixel, and then we're going to say weight. So that's how much percentage of the pixel it's going to take, of its color it's going to take. So the weight, and then kernel x. So this is going to be what pixel on the x-axis is going to take. And then we can go ahead and say, we could put it right next to it, text 2D proj, and then in dot uv grab dot x plus grab texture, underscore texel size, So that's how big the actual texture is. Times the kernel x, and then times by the blur radius. So it's going to move the kernel along. So instead of getting the pixels directly next to the first pixel that we want to change the color for, it's going to go, like, depending on the blur radius, either 2 or 3 or 4, depending on the blur radius, pixels away and get that pixel's color. So blur radius, and then I'm going to get in dot uv grab dot y, and then the same for z and w. And then we're going to times all that by the weight. Got one part at the beginning. We want grab texture. And then comma, unity, proj, chord. And then at the end, we want, then we want all of this in a float for. And then right at the end, you need another bracket. So this is the function of getting a pixel's color and by how much weight you want of that color. So it picks a pixel, depending on the kernel, away from the pixel that we're currently on, and the blur radius, and then depending on the weight, grabs that amount of color from it, and then we're gonna use it in a sec to add it to the sum. So we can go ahead and do that now. So if we do text sum plus equals grab pixel, and then we just start with 0.05, 0.05, and then negative 4.0. And so this is the weight, and this is the kernel. We're going to copy this a couple times. So 1, 2, 3, 4, 5, 6, 7, 8. So we want 9 of these all together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we're going to change these numbers. So it's going to be, this one's going to be 3, and then 2, 1. This one's just going to be 0. And then we're going to go back up the other way. So 1, 2, 3, 4. And then we're also going to change the weight. So this is the furthest point away from, the furthest pixel away from the pixel we're currently on. Depending on the blur radius is how far it actually is away. So it's going to have the least amount of weight. And then 3 is a bit closer, so we're going to do a bit more weight, so 9. And then this one's a bit more closer than that, so we do 12, and so on. So 15, and then 18. Oh. And then we go back down the other way, so 15, 12, 9, and 5. And so now this should go through all the pixels on the horizontal axis on the for the X kernels and add up the colors so it gets one big color, and then it's going to be a blur, so it loops through no blur and some blur depending on the intensity. Now we just need to do the same thing but on the vertical axis. So if we go ahead and go down, if we get the imports, go down to the vertical, and we'll call this vertical blur, and we want to change the imports to the same, but just before the pass we want to do another grab pass so that this grab pass here will grab everything behind the object, and then it's going to blur on the horizontal, and then this grab pass is going to grab that blur that just happened and put it into this pass, and then we're going to need to change this stuff to match the one above, so we can get rid of app data, however you want to say it, change that to base, and then we could change v2f again, like that. And then the vertical function, or the vert function is going to be exactly the same, the vertex function. So we can just copy out the contents of this and stick it into this one. Just retabify it. So that should work. And then we can go ahead and copy this frag, but we're going to change it a bit so that it works. So just replace this one with that. And then we're going to need to change this kernel to a Y kernel. So kernel Y. And then I'm going to just put this down here for a sec so it's easy to read. And then we can move this to here, like that. Remove it from here. And we can times that by Y, kernel Y, and then grab textile size Y. And now this should work for a blur. So let's test it out. Just move this back. Yep. I accidentally typed another underscore here, so I'll delete that. And I didn't type 4 here, so I'll put that in. Spelled kernel wrong. So let me replace that and go down to here and replace that also. Kernel Y, there we go. I forgot a semicolon here at the end of the lip functions, and the other double underscore, and the other half for. I accidentally left a comma in after the in.uvgrab y for the grab pixel in the vertical blur. Now that we got all those errors fixed, which is kind of bound to happen with no IntelliSense, we can go ahead and open the Unity, and we can put the new shader on. Oh, we should make a new material. Create material, we'll call this one blur, and we can just drag this blur on in custom blur, and we should just make a default texture as well. So material, we'll just call this textured. Put custom, and then apply texture. We can just put just a checkerboard pattern or something on it. We're gonna put on cube 1, cube 1, we're gonna put the normal texture, and on cube, so the one that's in front, I'm gonna put the blur. So right now you can just see directly through the cube, but that's because we need to set our blur intensity up, and then you can see everything behind the cube is getting blurred. You can change the radius as well. So great, we made a blur shader. Now to make a distort shader. So what the distort shader is basically going to do is you're going to be able to see through it and put a color on it, and you're also going to be able to apply a bump map, so that we can, when we combine the two, the blur and the distort, it will blur things in a certain way, and it will also distort them using a texture map. So let's go ahead and copy the blur and get on with it. So Control D on the blur, and we'll call this distort. And we can open that, change blur to distort, and we only need one pass for this, so we can go down and delete the other pass, like that. great. And then we can rename this to distort. And then we can delete these properties and replace them with distort color. So distort color, and we can name it distort color. And this has the property of a color. We can set the default. And then go ahead and make a bump amount for how much distortion there's going to be. And we can just name that distortion. And we want to set that to a range of 0 to, let's say, 128. And we can default it to 10. Then we're going to set the actual distortion texture. So distort text, and then this will be the map that goes onto it, or the texture that goes onto it. So we'll call it Distort Texture. And it'll be RGB. And then this has 2D texture. Close that off. And we can default this to be white. And then the last thing we need is a bump map. So the actual distortion. Or a normal map. And this will also be a 2D texture. And call it defaulted to bump. And like that. Go down and recreate app data for this. And then we're going to need a float for vertex, and that will be position. And then we're also going to need a float 2 for a text code, and text code 0, and we can put that back in. And then with the vertex to fragment, we're going to need to change this up a bit. So this is right, and then this is right, but we also need two more things. We need float to UV bump, and that's going to be the second text code. So text code 1, and then we also need a float to UV main, and that'll be text code 2. Oop. Okay, so you save that. We need to change the imports, so we can go ahead and delete these, and we need the float for the bump amount, and then we also need the float 4 for the bump map. Bump map, and then underscore st, and then we also need the float for underscore distort text underscore st, and then we need fixed for distort color, and then we need sampler 2D grab texture, and then we need a float for grab texture texel size. And then we also need sampler 2D bump map, and also the distort texture. Down to the vertex function and remove the underscore base because we're going to use our own app data. And we go down. This is all good apart from at the bottom. We're also going to need to add information for the bump map and the distortion texture. So we can say out.uv bump equals transform underscore text, and then in dot text code, and then underscore bump map. And then we can copy this, put it here, and then for the UV main, we want distort texture. So this, and that should be it for the vertex function. So this should go ahead and apply all the positional data and build the object in the right way. Scroll down to the fragment function, and you can go ahead and delete this. And then we're going to need information for the bump. So we make a half 2 for a bump, and then we're going to unpack the normals. For text 2D, and then underscore bump map, and then we're going to get the in UVs for the bump, and then .rg, and then we're going to need float to offset equals bump times bump amount times the grab texture texel size, X and Y, and then we're going to need to actually offset it. So we calculated the offset due to the bump map, and then now we're going to actually need to offset the actual colorization by setting the in dot grab UV grab, so X and Y equals offset times in dot UV grab dot Z, and then also add the in dot UV grab dot X and Y. So that's going to offset the actual texture. And then we need to set the color. So half for col equals text 2D proj underscore grab texture, and then unity underscore proj underscore code open bracket in dot UV grab. And then we can also need to set the tint, so half. So this is for the texture you want to put on the distortion, and then this will be for the tint you want to put on that. So we'll call it tint equals text 2D, and then underscore distort texture underscore comma in dot UV main. Then we're going to times that by the distort color. And then need to capitalize that D. And then what we're going to return is the col times the tint. So the color times the tint. So what this is going to do is going to offset the material by the bump map, depending on the amount and the actual texture you put on it. And then it's going to get the color of the distort color from the texture, and then it's going to times it by the tint you put on it, and then it's going to return that. I actually made a mistake up here, and I didn't name it bump, I named it bombo. So also I named it transform instead of transform. The top in properties I added an extra bracket. So misspelled grab here at the bottom in the fragment function. Also in the fragment shader, in the fragment function, misspelled bump in the when I set bump. And I forgot to capitalize the G in grab texture. Oh, there we go. I also forgot the B in grab down here in the fragment function. And I also forgot to capitalize the T in text. Also in app data, I forgot an O to make it text chord instead of text chord. Again, there is no IntelliSense, so you're going to make a lot of mistakes if you're not careful. But now that everything's cleared up, we should go back into Unity, and we should be able to see this distort at action. So if we make a new material, just material, we'll call it distort, and we can drag the distort shader onto it, and then we go ahead and apply this to the normal cube, the one in front. It's going to look like nothing's changed, but we can change the distort color like that, so it changes everything behind it. And if we just move the camera real quick so you can actually see it in the game. Just make it bigger. Move this around. Alright, now we can actually set a so this is the distort texture. So this is like if we change the distortion all the way up also, and we change the color, you can kind of see that that's like the texture of the thing. But then if we go ahead and go into the bump map, it's going to distort it based on the bump map also. It looks different with different normal maps and distort textures, so you can have a play around with that yourself. And then the last thing we're going to need to do to make it all come together is make one final shader that combines all of them. But to do that, we're going to need, just make a new folder, we're going to need 2 different blur and distort shaders that are a bit different so that they actually scale to the size of the outline. So if we call this final shader, and we duplicate the distort, put that in there, and we duplicate the blur, put that in there. We can also just drag the outline straight into there. Actually, we don't need the outline. We can use the apply texture instead. And we rename this to outline blur, and this to outline distort. Whoops. And then we go ahead and open these up. So outline blur, just add the outline to the thing. And we rename this to outline in front of it. Just copy that. Go down to the vertical blur. And then we can go into the distort as well. Add outline. Now to actually make these different, we're going to go back into our normal outline shader, go down to the top vertex where we actually make the outline, and we're just going to copy this little line that times everything by the outline width, and then we can go into our outline blur again and just add this to the both vertexes. So we get that vertex and vertex function, so these two, and then we could also put it in the outline one, or outline distort one. So put that there, and then we're also going to need a what is it called? Outline width. So copy that. We can put that at the top of both of them, and then we're going to have to also import it, so we can just copy the import text from here. So outline width, put it into the blur, put it here, also in this shader, and then we're going to also need to put it in the other part of the blur, and then in the outline blur, we'll also want to add plus 0.0. How much do we want? So if it can scale from blur intensity if it can scale from 1 to 10, we want to add 0.1 to it so that it blurs the whole thing. So you'll see what this does in a second. So we can add this to the other one. Alright. And now we can create the final shader. So if you go back into Unity, and in the final shader folder, we can create a shader. We can just copy the apply texture one. So Control D, and we'll rename this final outline. We'll just call it border. Yeah, we'll call it final outline. So open that up, rename it. Go ahead and delete all the entire pass. And then we're going to need to add the properties of all the different shaders we made. So the first one we want to get is the default, not the outline pass of the outline, but the actual object pass. So all the information that goes into there. So these two properties we'll put into our final shader. And then we're also going to need the outline width, because that goes into the two shaders we made. And then we're also going to need the blur properties. So if you go into blur, go to the top, grab the blur radius and intensity, put that here, and then we also need the distortion. Outline, blur, distort. And then we can put that at the bottom. Now that we've made all these shaders, we can actually call the passes in this one shader. So we're going to get the grab pass of just everything behind the shape, and then we're going to blur it. So we can go ahead and say use pass, and then we're going to call custom, and then we have outline blur, and then outline. Oh, we can actually just copy this. So I go to outline blur, go to the top, copy that, and then copy the outline horizontal blur, and then put that in the end. So it's going to use the pass, it's going to horizontally blur everything behind the object, and then we can copy this and do it again, but with the vertical blur. So replace horizontal blur on the next line with vertical blur, and then we're going to need to distort it. So we got to grab it again. So this grabs nothing. This grabs everything behind the object. This blurs it, and then this grabs the horizontal blur, and then adds a vertical blur, and then this grabs both of them together, and then this will blur it again. But we need to go to the outline and go to the outline distort. We put this in the whole wrong thing. One sec. Control Z it. Oh. Alright, I accidentally opened the wrong one. So we need final outline. Here we go. The custom. Okay. Oh. Alright. And then we need to get the Distort Shader, so we can go ahead and outline distort, put that instead of outline blur, and then we're going to grab the pass, which is outline distort, and put that pass here. And then instead of getting another grab pass, we're actually just going to want to draw another shape on top of this one. So we're going to need to go to the outline shader, go down to the object, and then we can use it. So use pass custom slash outline slash and then object. So now this should work. Let's just try it out. So if we save it up and then go into Unity. Just before that, we're going to want to add Z-Right to both the outline distort and the outline blur. So turn it off, I mean. So Z-Right off. And we're going to add that to the blur as well. So Z-Right off. Also need to add it to the second pass of the blur. So Z-Right off. And we're also actually going to want to change the positioning of the distort. We want to change it so that that happens first. So it distorts everything. So it grabs everything behind the shape, it distorts it, and then it blurs it. Because if you have the blur first, then the distortion doesn't get blurred. And so you can see the edges of it really well. And you don't really want that. And then you add the object in the end. So let's go ahead and try this in Unity. Okay, now that we're in Unity, we can create a new material, and we'll call this final outline, and we'll add the custom final outline, and we can select the default texture, make the color like that, the width is okay, blur radius is okay, we can set it to 1.1, the intensity we can turn all the way up, the distortion color we'll set to like a red. The distortion we want all the way up, and then you can set these yourself, but right now I'm going to apply that. And then you see we have the outline, and if I move the other cube, you can see it behind it like that, and it blurs it and also distorts it if you put on a bump map onto the actual material, so onto here. And then you can also change the width and anything, all the settings you can change. And then one last thing is I'm going to show you a script on how to make this border appear once you hover over an object. So go ahead and make a script, so C# script, and call it on hover border. And then open that up. And once it is open, you can delete these two usings statements because we don't need those. Like that. And then change the formatting. Okay. We're going to need two public materials, so we'll call this border, border, and public material, and we'll call this non-border. And then we can delete these two as well, because we don't need those. And we can have void on mouse over. Just delete that. So on mouse over, so when the mouse is over the object in the game view, do get component and then renderer. And then we can have the material of the renderer, and then equals border, and then we can have on mouse exit, on mouse exit. We can have the same thing, but we can change it to non-border. And then that should work. So let's go try it out. Let's go set up a scene in Unity. Okay, so we have the final outline material, and we also have the textured material. So if we go ahead and click on the cube and put the normal textured material onto it, we can also add this script onto it by just dragging it on. And then we can have the two materials in here. So we can have bordered, which is the final outline one. And then we can have the non-bordered one, which is the textured. And then we can set up a nice scene by, make this a bit smaller. Delete this other cube. And then we could just duplicate this a couple times. So duplicate. And select both of them. Duplicate. Move it out. And then we can duplicate all four. And then we can duplicate all 8. And then move it up. And then we can set our camera up to see them all. Just move it around. Okay, and then when we press play, when the mouse is over it, it sees the material and it puts a border around it. But if we want to change it so that the final outline color is white, so it doesn't look like it's changing, now when we hover over it, it just looks like there's a border around the shape. Great. I hope you enjoyed my tutorial on the introduction to shaders and have fun using the outline shader that you just made.